Well, hello everybody. Welcome to today's Tecplot webinar titled Back to the Basics on TecIO. Looks like we have quite the global attendees today. So I'm in the Pacific Northwest of the United States. It's 7 a.m. here, so good morning for those of you who are over here on the continental US and in this time zone, and good afternoon for those of you who are out in Europe and elsewhere. This webinar is going to run on the order of 30 to 45 minutes, and we'll have time for questions and answers at the end, and we'll get into it. So presenters today are myself, Scott Fowler. I'm the product manager for Tecplot. I've been the product manager for about the last 6 years, and my history at Tecplot prior to that was mostly on the development side as a C and C++ programmer. And I'm joined today with Dave Taflin. He's our senior software engineer, developer, and is one of his roles at Tecplot is to develop and maintain the TecIO library. And Dave, why don't you take a little time to introduce yourself so we can all hear your voice?
Hi, I'm Dave Taflin. I've been with the company for a little over 25 years. I was hired to do computational fluid dynamics research, which is what my PhD was in. The company shifted gears a few years thereafter and were kind enough to repurpose me as a more general software developer. I started out in Fortran, and it's still my first love, but I also program in C++ and a little C and a little Python here and there. And I'm pleased to be with you this morning or afternoon.
Great, thanks, Dave. So Dave is going to be on hand to answer any questions during the webinar. So as we're going through, feel free to participate by asking questions in the question answer pane. This webinar is also being recorded, so you'll be able to review this information at your leisure, and a link will be sent out to you after the webinar. So for those of you who may be new to Tecplot, I'll just go through a quick review here of who we are and what we do. We were founded in 1981 by a couple of Boeing engineers who were doing CFD, hence Dave's comment about being hired at Tecplot to do CFD. And a while after they started Tecplot, they realized they needed a great way to visualize their CFD results. So they hired a developer who's also still at Tecplot today, and we've really built and created this tool, Tecplot 360, that you all know and love today. In that time, we've amassed about 47,000 customers worldwide. We're also known as being the most complete desktop post-processor with XY, 2D, polar plotting as well. And then we're also dedicated to saving engineers time. So again, how do we do that? We do that through innovation and innovative data file formats. So we've done that with our SCPLT file format, also known as SIZL, which stands for Subzone Load on Demand. We'll talk about that a little bit today. And the image you see here is a visual representation of what the SIZL file format gets you. Most post-processors and most file formats require that, to create a simple slice like you're seeing in that upper left, that you have to load the entire volume grid. Well, the SIZL file format breaks down the volume cells into smaller chunks. So when you create that slice, we only need to load the chunks of data that surround that slice. That saves you time because you're loading less data off disk. It also saves you RAM because you're loading less data into memory. So you can get away with much lower spec hardware for doing the same problems. We also have a companion tool to Tecplot 360. So when you buy Tecplot 360 and have active maintenance, you get with it Tecplot Chorus, which is designed around doing designs of experiments, understanding ensembles of data. So if you're in that state, if you're doing any DOEs, if you're doing any trade studies, Tecplot Chorus might be a great product for you. We did a webinar just a couple of months ago on Tecplot Chorus, so I encourage you to seek that out. And then automation. We all know that you have to do more and more CFD, therefore you have to process more and more results. So having a good scripting layer is a great way to automate your work and get more analysis done. So we have two scripting layers. We have our macro language, which has been built into Tecplot for effectively forever. And we also have a Python layer that was introduced in 2017. The Python layer really helps with additional data analysis because it gives you direct access to the raw data that you've loaded, so you can pull that data out and do additional statistics on it that you may not be able to do any other way. So we've also done a couple of webinars on Python over the past couple of years. We've done 2 recently, so again, please seek those out on our website. All right, well, let's get right into it on TecIO and today's agenda. So this is a back to the basics webinar, so it's really going to be a high-level overview of what TecIO is, why you should use it, etc. So that's that first bullet, what it is, why you should use it. Then how do I get TecIO, and is it free? Well, spoiler alert, yes, it's free, and we'll talk about how to get it. You don't have to be a Tecplot paying customer to get it, which is great. Do you need to compile it? Where can you get the example code? And then we'll walk through a couple of code examples, and then we'll talk a little bit about some research code that we've written on TecIO in what we call In-Situ, which is, In-Situ means a lot of different things to a lot of different people, so we'll get into the specifics of that. Okay, so what is TecIO and who should use it? Well, TecIO is a library that we've written to read and write Tecplot binary files, PLT and sizzle file formats. You see the little asterisk next to read. We have APIs to read sizzle formats, but we don't have APIs to read the PLT format. Now, the PLT format is an open published format, so if you do need to create a reader, it's pretty simple really to create readers and writers for the PLT format. But again, you can use the TecIO library to write PLT anytime. Now, if PLT is an open format, why should you use our library? Well, it protects you against any format changes that we might make to the file format over the years. It's been pretty stable for probably the last 8 years, but that doesn't mean that we won't change the file format internally in the future. So if you use this API, you're going to be protected against any of those internal file format changes. And this library is available in C and Fortran, and like Dave said, Fortran is his first love, so we keep Fortran here, and we know that Fortran is a very popular language in scientific computing. Okay, so who should use it? Well, really anyone who wants a fast, reliable way to store their data in Tecplot file format, any CFD code developers, PIV users and hardware suppliers. So we have a lot of people who are using Tecplot with PIV data. So the TecIO library is a great way to get your PIV results into Tecplot format. And then SU2 and Fun3D are a couple of codes that are available that actually bundle TecIO with them. SU2, the TecIO code is bundled with SU2 in their repository. Fun3D does require a separate download of TecIO from our website, but then if you compile Fun3D with TecIO, you're going to be able to get either PLT or SCPLT output. If you're compiling Fun3D and running it in parallel, we highly recommend that you use TecIO MPI, which is our parallel version. We'll talk about that in a little bit as well. Okay, so how do you get it? If you're not a paying customer of Tecplot, you may not have an installation of Tecplot 360 available to you, but you can get it for free via our website, my.tecplot.com. You can register for that without being a paying customer and download it. You see the little screenshot on the right, and it gives you a little hint of where to go to get the TecIO library. And that's going to give you a package that has the source code so you can compile it yourself. Jumping back up to the first bullet here, we do supply pre-compiled libraries, and there are headers included in the Tecplot 360 installation. The pre-compiled libraries, they're shared libraries, and they're in the bin directory underneath the Tecplot 360 installation. The include files are in the include directory directly under the Tecplot 360 installation. If you need static libraries, you may need to compile, and we'll get to that in a minute. So here we are. Do you need to compile TecIO? Well, the answer is maybe. So if you're okay with shared libraries and you're using the same version of MPI that we compiled Tecplot with, you can get away with what we've distributed. But if you're using a different version of MPI, which is quite common on Linux and Mac platforms, there are a lot of versions of the MPI libraries out there, you'll almost certainly need to compile TecIO yourself. And then also, back to my previous point, if you need a static version of the library, you'll need to compile it as well. And there are instructions for compiling it in the source code distribution that you can get on the myTecplot site. So those are the build instructions are in the readme.txt file in that source distribution. And while we're here, why don't I just give you a little tour of what that source distribution looks like after you download it. So when you download it, I believe it's a tar.gz file, and you unzip it, and here are the contents. So right in here we have our top level directory, TecIO source. We have example code in the examples directory. If you need to compile the MPI version, we have the MPI source, the serial version of the library source code here. Tecplot data format guide, which is a great resource for you when learning about our file formats and the API that you'll be using in the TecIO library, and a top level README. Now this top level README really just kind of drives you down into either one of these. So let's jump into the TecIO MPI source, and we'll look for the README here. And let's bring this up in Notepad++. And you can see here that we have all of the information that you need about the library. We do have a license agreement that we ask that you read. It's a very permissible license agreement based on the MIT license. So really there should be no problem in adopting this code and using it yourself based on that license agreement. There are some prerequisites here and then instructions for building the library. And you'll see that we do have instructions for using CMake, which is an open source build configuration tool. So if you're not familiar with CMake, there's plenty of documentation on the internet about CMake. So again, I'm not going to go through an example of actually building TecIO today, but there are plenty of instructions there. And if you ever have problems building the library, you can certainly contact us. Okay, we talked a little bit about the two different file formats that the TecIO library can produce, Tecplot's binary formats, the PLT and the SYZL format. Again, SYZL standing for Subzone Load on Demand. So which format should you use? And in most cases, I'm going to say the answer is the SYZL format. It's our newest format. It provides a lot of benefit in that the MPI version of the library, if you're using MPI, can only write SYZL. So that's one of the keys, and that's in part because our SYZL file format will store data in a partitioned manner. So as you partition your grid and are doing your computation in your CFD solver, you can write those partitions or send those partitions directly to the TecIO library to deal with. You can use our SYZL server tool. So when you buy Tecplot and again have active maintenance, we have a component called SYZL Server, which provides a client server type connection to your SYZL data, where we serve up just those subzones required through the connection. So you can effectively get access to remote data. You do get faster load times, like I pointed out during the introduction slides in Tecplot 360, and reduced memory use. This is a file format also uses a node map compression. So if you have classic unstructured elements, so that would be bricks, tetrahedrons, etc., we are going to compress the node map, which can save anywhere from, we've seen 10 to about 40% node map compression, or actual total file size compression, because for very large cases, the node map can really dominate the size of the file. So you get some lossless compression with the SYZL format. Again, you can use TecIO to read these files, and then if you're interested in this research work that we're doing, that I'll present later, you could use TecIO for this in-situ export concept. Now, you may be forced to use the PLT format, and there's nothing wrong with using the PLT format. It's a well-known and well-supported format. We're not going to drop it, or it's not going to go away, but the PLT format is going to be required if you're using polyhedral cell types. the Sizzle format doesn't support polyhedral yet. So if you're a user out there that says, geez, Sizzle sounds great, but I need polyhedral, let me know, and we'll see if we can get that on the development plan. It's a big job, which is one of the reasons why we haven't done it yet, but I understand that more and more people are doing polyhedral, so I want to hear from you. PLT, like I said, also is a published format, so you don't have to use TecIO to read and write PLT. The Sizzle format, it's a pretty complicated format under the hood, and we haven't published it yet. Okay, so where can you find documentation and example code? We kind of already went through that in the TecIO source code distribution, which we'll jump back into that folder again. So again, the Tecplot 360 data format guide and the examples directory, we have quite a lot of examples here that can be useful to you. I like referring to the IJ ordered and IJK many. Those are good for structured data. If you're using unstructured or polyhedrons, you can see some of the ideas here. So brick, that's going to be classical unstructured, brick partitioned, that's going to use the partitioning APIs that we have in the TecIO library, or for dealing with partitioned data. You can see that we have some polyhedral ones with polygons, octagon, poly here. Rewrite Sizzle is a really nice one. This kind of runs the gambit of all of our APIs for reading a Sizzle data file and then writing it back out. So that's a really handy one. So lots of good examples in there. Some of these, most of these are C examples, but we do have some Fortran examples in here, so you can kind of pick your way through the examples to find the Fortran ones. And then the data format guide, that's that PDF. You can see I have a link to it on our website here as well. Chapters 3, 5, and 6 are going to be your critical chapters in that document for understanding the APIs. Okay, and as you go through that documentation, you might think, wait, what? You have two APIs. Why do you have two APIs? What we call, we haven't got good names for these yet, so we just call them old and new API. So the old API is characterized by the functions all being in all caps and starting with tech, and then usually followed by a short three-letter abbreviation of what that function does. So TecINI is your function that will open and initialize a file. TecZNE is going to add a Tecplot zone to the data file. And then TecDat is going to add the variable data for each one of those zones to the file, etc. So this old API, you're going to want to use this if you need to support PLT and Sizzle, or just PLT in general. Now, the data types are defined for the entire file. So you're limited to single precision or double precision for all of the variables throughout the entire file with this old API, even though Tecplot 360 itself does support multiple data types for variables. So the TecIO library is limited in that way. It's also characterized by somewhat long parameter lists. So if you look at TecZNE, for example, that one function has parameters that work for structured data, unstructured data, and polyhedral data. So you may encounter parameters that you don't need for your use case in some of those functions. And then if you are in a situation where you're trying to write multiple files at once, it's somewhat difficult to support that with the old API. So the new API, now both of these APIs, Dave, maybe you can correct me if I'm wrong here. The old API I know supports C and Fortran. The new API, does that also support Fortran, Dave?
Yes, the Fortran interfaces for both the old and new APIs are in the same files, TecIO.4 and TecIO.f90. These are both F9 Fortran 90 interface files. The only difference is the format that they use.
Okay. Yeah, and just to kind of come back to that point, again, in the distribution. TecIO.h is going to be a good resource for you for understanding all of the functions that we have and the types, and then also Tech90, or sorry, F90. Thanks, Dave. So the new API supports SYSL files only, and remember there's no polyhedral cell type support with the SYSL files. The data types can be supported or changed per variable, and actually per zone per variable. So let's say your grid single precision is fine, but your solution data you want to be double precision, or let's say you have some variables which need to be double precision, and then other variables which are a categorical type, like maybe a soil type, and those can be represented as integers. You're going to be able to create a smaller data file because you have this flexibility in which data types you can specify. Again, shorter parameter lists because the functions are going to be a bit more focused on what you're creating. So you can see here we have a tech zone create FE. So this is going to be a function that's for creating your finite element types. And it's going to have a much shorter parameter list than you would have with tech ZNE, which is just general for all of the cell types, the zone types. And then this API also uses file handles to more easily support multiple file types or multiple files. And we also, as you'll see in the source code example, we pass actual zone and variable numbers down to the functions, so you can write your data out of order, so to speak. Okay, so let's get into a couple of code examples. So this example comes effectively out of that IJ ordered example. So I've taken the liberty of removing a lot of the code that sets up some of these variables and some of the intermediate code, but just to kind of show you the general calling structure of how to create a Tecplot PLT file, in this case, using our old API. So TecIO, this is a function that is going to initialize the file. It's going to tell us the name of the data set. So all Tecplot data sets have a data set title. So that's this first parameter. A list of variables. So in this case, it's a space separated list of variables. The name of the file, and then some additional information for how we want this file to be constructed. So file format is going to be whether you're doing PLT or the SYSL. File type is going to be whether this is a mixed grid and solution file. So that's where you have the grid and solution all in one data file. Tecplot PLT and SYSL format also supports separated grid and solution files. So if you're writing out just the grid, you would pass a different value here. If you're writing out just the solution, you would pass another. So 3 options for that. The debug flag, so you get extra output on the command line if you turn on debug, and then again, we only support single precision or double precision, so you pass a parameter here. So once I call this function, a file will be opened and created, and then I add a zone to it. Here I'm adding just one ordered zone of a specific IJK dimension. Give it a solution time and strand ID if it's transient, whether it's block format, and I believe this is required now to be block format. I don't think we write point format. Dave, can you correct me there?
Yeah, that's correct. We take only block format now.
Right, and the reason for that is block format is just much more efficient to both read and write, because you're writing just a big block of data into the data file. So this is effectively a deprecated parameter. And then, like I said on the previous slide, a lot of parameters here that you may not need because they're pertinent to other zone types. Okay, one of the other things that characterizes this API is these functions to add the variables to the data set. You have to call these in the order that the variables are expressed up here. So we've expressed it as X, y and p, so my two grid variables and a solution variable, and I need to pass those arrays in that exact order, because the old API and the PLT format allows us to really just stream the data right to the file. So we're writing all of this in order right to the file. And then when we're done, we call TecEnd. So this is the really simple structured data example. If you're doing unstructured data, polyhedral data, there are some additional calls that you have to make to add the node map and define that cell connectivity. But really for structured data, it's just 4 function calls that you have to know about. So pretty simple. Now the new API is a little bit different, but kind of the same. So again, if we look at the structure of this, we have a function to open the file, create the zone, add the data, and close it. So again, really a pretty simple set of functions here as well. I've added a little bit more fluff at the top here to initialize some of these variables so you can see what those actually are. So file format, the value of 1 is going to specify that it's a sizzle format. File type 0, this is a combined grid and solution file. Default data type, so I've passed a 0, single precision. That's Dave. Now I got caught out on this during our practice. Can you explain what the default data type does again?
Right. First, just to skip back to your first line, a reminder that if you're using the new API, you are going to get the sizzle format. We put file format in there anticipating that we might eventually support PLT output from the new API as well, but that is not the case today. So back to your question, Scott, for TecFileWriter Open, the default data type is the data type that will be selected if you pass null in place of the var data types array down below.
Okay, great, thanks. So kind of like the PLT format, you can just kind of rely on, it effectively creates a data type for the entire file, and then you can be more specific per zone and per variable by passing this additional array. So TecFileWriter Open, again, we're passing the file that we want to write to, the dataset title. The variable list here is now a comma separated list rather than a space separated list, which actually helps a little bit because we do have people who want spaces in their file names. So you couldn't do that with the old API. So nice little addition there. And then you can see that we're passing the other values. Now we are passing a file handle as well. So now I have a handle that I can use to pass to the rest of my functions. So I know exactly which file data is being written to with each function call. Now creating the zone, again, it takes the file handle, takes the zone name, takes the IJK dimensions. And as we said, in this case, I wanted to show that you can use different data types for each variable. So in this case, my grid variables are both going to be single precision and my solution variable is going to be double precision. So I'm passing this array to instruct the zone that that you have those two different data types.
Looks like you've got additional... a typo there too. Var types and your call should be var data types.
Yeah, thanks, Dave. So clearly I haven't tried compiling this code. Okay, and then we're going to finally write the data to the file, or to the zone rather. So we pass the file handle, which zone we're writing to. And in this case, we're actually passing, like I indicated before, the variable numbers. So I can make these calls out of order if I wanted to, because I'm actually passing a variable number here. You can see that I'm calling write float values and then write double values for the solution variable. One thing to note about the TecIO API is that it is one based when it comes to the zone numbers and variable numbers. And then finally, we close the file. So again, fairly simple. We have a little bit more flexibility with this new API, and in all reality, a little bit easier to use because you can make these calls in any order. Okay, so that's done with the examples. At this point, you should have all the resources you need to be able to dive into TecIO, where to get the source code, where to look for the examples. The examples are actually installed with Tecplot 360 as well. So if you have Tecplot 360, you can look at the examples there. So you can get started without having to go to our website and do the separate download. But that TecIO care package, as we call it, is available on the website, and you can download that. So let's transition now into some research work that we've done, and we're kind of trying to find people who are interested in utilizing this. So we've done some. We know In-Situ is kind of a hot topic. Data set sizes are getting bigger, simulations are taking longer, and how do you post-process that data or analyze that data in a fast, efficient manner? So In-Situ means a lot of different things to a lot of different people, and we've kind of co-opted this term a little bit. So for a lot of people, In-Situ means that you are doing the post-processing live in memory while the solver is running, and that's typically what we call in-memory In-Situ. And then there's another type of In-Situ called in-transit, where data is transferred from the solver memory to a dedicated node for post-processing, so you're not interrupting the solver. And this is a little bit more on the in-transit side, where the research code that we've done will allow you to make an additional TecIO function call that allows you to specify a range of values for a variable. So in this case, say for instance, you're doing a combustion simulation and you only want to write out the points that represent your flame front, which are say in the region of 2000 degrees. So you could make an additional function call to say to TecIO, only write the cells that are within 1900 to 2100 degrees. And in our experimentation, we've seen that this technique can result in up to about a 93% reduction in file size with no actual post-processing being done on the solver side. All we're doing is filtering the cells that get written to the data file. So this should be cheaper than doing an isosurface in memory with the solver, and then you have these volume cells that you can actually move an isosurface around a little bit. So we have a couple of white papers that are attached to this webinar that you can read. These were also presented at the last time we had an AIAA conference in person. We presented these papers. So I do encourage you to take a look at that and reach out to us. You can contact support@tecplot.com to get access to this TecIO library, and they'll put you in touch with me and our CTO, Scott Imlay, who's the primary author on these papers. Dave Taflin was also involved in each of these papers too. Okay, so with that, I've gone through the content of the webinar today, and we can open it up for any questions that you may have. So Dave and I will just hang on the line, and if you have any questions, please go ahead and type them in the question and answer pane. It looks like we have a couple in there already. Dave, let me ask this first question to you, and you can respond. It says, is there an easy way to convert PLT files to sizzle files? You want to take that one, Dave?
Well, the only easy way really is to use Tecplot itself as your conversion tool. Now we do have a special command line option to do that, so you can do that more or less in batch mode without consuming a license. As I sit here, I can't tell you exactly what the syntax for that is, but it is documented. It's something like, tech360-convert, and then the input file and the output file names or something like that, and it'll read a PLT and convert it for you to a SCPLT.
Yeah, and I want to say that there was also a -O thrown in there somewhere. So, but yeah, look in the documentation for command line and look for convert, and that'll get you on the right track. One of the interesting things about that convert command, like Dave said, it does not consume a license, so you can do that data file conversion without consuming, effectively unlicensed. And you can also convert other formats as well if you pass a Tecplot macro on the command line. So you should be able to have a macro that just has our read dataset command. So if you wanted to say convert a CGNS file or Fluent to Sizzle format, as long as the macro only contains the read dataset command, it'll then load that data and then convert it to Sizzle format. And here's another question, Dave. It says, are integer types faster for post-processing or just space savings?
Well, they should be faster to read and write because they can be smaller. Now, if you're using 4-byte integers versus floats, which are also 4 bytes, I wouldn't expect any difference there. But they should, smaller ones, 1 byte and 2 byte integers should be faster to read and write. That's about the only speed advantage I can think of. Tecplot itself does all of its processing with all of its plot generation in floating point. So even if the data are saved in an integer format, all the slicing and all that is still going to be done in floating point.
Yeah, and I believe most of the data arrays in the core of Tecplot are double precision. So yeah, while the rendering may be floating point or single precision, the data processing side is all double precision.
Yeah, now in RAM they'll still be integer arrays, but as soon as Tecplot tries to do anything with them, any values that it recalls from those arrays will be immediately converted to doubles.
Yeah. Okay. Well, it looks like just 2 questions so far, and we're always here. So while you're thinking about other questions, or maybe I've answered all of them, I will make a plug for our support staff. We do have staff on hand in North America. We're available 6:30 a.m. to 5 p.m. Pacific time, 5 days a week. And then in Europe and Western Asia, you have our staff in Regensburg, Germany, support-eu@tecplot.com. They're a great resource for you if you're over there in that time zone. And then if you're outside of those 2 regions, I do suggest that you reach out to your local distributor if you need any help, because they're in your time zone and they're going to get you the best response time. And you can find your local distributor at tecplot.com/distributors.
Hey Scott, I've got a question.
Sure.
You mentioned this My Tecplot account. How do you get one of those? And when you get one, are you signing up for any spam?
Good question. So my.tecplot.com is our, we call it our customer portal, but you don't have to be a customer. So you just go to my.tecplot.com and you can create an account. We do have to validate you as an actual human being, so it can take a little bit of response time from our support staff to approve your account. But then once you're signed in, you can opt in to any marketing emails. One of the great things about having an account there is if you opt into TecIO, you'll actually get updates for when we make changes or bug fixes to the library. So it's probably a good idea if you're using TecIO to register for that account anyway. Oh, this is a great question that just came in. How do you write from MATLAB? Good question. We actually did a webinar on using the C version of the TecIO library within MATLAB. So MATLAB has this neat capability where you can actually import a C library and make function calls. So you can use the TecIO library from within MATLAB. And which reminds me that we also have well, I have a little pet project of creating a Python wrapper to our TecIO library. So if you just Google Tecplot GitHub, you'll get to you'll find a GitHub site with some Python code, and you can see Python a thin Python layer for TecIO. And if you search for Tecplot MATLAB, maybe we can just do this as a team here. We've got a few people still online, so let's just go to Tecplot GitHub. If you go to Handy Scripts, Python, data conversion, there are a couple of TecIO Python files here which are incomplete, but they can get you started. So you can see we're using the Python ctypes library to load the shared version of the TecIO library, and then you can see that we have wrappers to some of those TecIO functions, and then we also have one that utilizes the new TecIO API. So this can serve as a source code resource as well. And let's see if we can find the MATLAB webinar that we did a while back. Yeah. So this is another interesting resource for how to use TecIO with languages that we don't natively support. So there's some neat tools there. So thanks for that question. Okay, well, that does it for the webinar. I'm going to go ahead and mute myself, but I'll stay on the line here for another minute or so. And if any other questions trickle in, I'll go ahead and try to answer them. But if not, again, please contact support@tecplot.com for any questions. Dave, thank you for your time. Always appreciate you as a great resource.
It's been a pleasure.